0.3. So again, to show that and kind of get used to showing that, we're going to divide each side by 0.3. So the 0.3's get to cancel. Something over itself is always 1. And so again, grab your calculator. It's fine to do that. 2.4 divided by 0.3 actually works out to be a really nice number. What did you guys get? 8. It's really like 24 divided by 3. So we ended with 8. All right, so in number 2. So remember, we did reverse order of operations on these. So we want to add or subtract first, and then multiply or divide. So in this case, what's being added or subtracted to the x? Yeah, we want to get rid of that 7.1 first, because that has the addition to the x term. So in order to get rid of it, we're going to subtract 7.1 over. 7.1 minus 7.1 is nothing. So we just have a 3x equals 7.5 then. And again, it's okay if you need to grab a calculator. I don't expect you. I know there's nervousness around doing work with just the decimals. And then to get the x alone, we're going to divide by 3. And what do we get for our x then? 2.5? And so being comfortable is showing those steps and be able to find that answer is kind of part of what we're doing here today. Okay? Okay. I'm worried about you over there. All right. So we're going to talk about two-step equations involving fractions as well. And then if you flip to the back side, you're going to notice we're going to do a bunch of word problems, which I know are like everybody's favorite. So I know they're really not, but we have to do them and still go through them. Oh, you guys know what? I have my Spanish notes up. Did I have those up the whole time? I didn't even notice that. No one said anything. Did you guys notice those Spanish before? I opened up the Spanish version. Can do cross-lingual math. Figures. Okay. I'm going to open up the other ones. Hope I swear it's usually not this much of a mess. I apologize for first day here. A mess. Shows how much you guys read the directions that you guys just like were okay with it being in Spanish. Like you were like, whatever, shoot. I don't read what she writes. Okay. All right. So solving with a single fraction. So these types of problems are kind of like, you can almost consider them like a little bit of a special case. So you have to kind of think about them a little bit differently. So we want to get rid of the fraction. And so what I'm going to suggest that we do to get rid of that fraction is we're going to use the denominator to get rid of that. So we kind of want to try and get rid of the fractions if at all possible. So for example 1 here, any thoughts on what we're going to do first? So it kind of breaks the rules a little bit. What do you think?
I was going to say, since it's dividing by 2, then multiply by 2.
Yeah, and so like sometimes use your intuition a little bit. She's like, it seems like we're dividing that all by 2, so why don't we multiply by 2? And so using a little bit of, the rules don't always work. Like you might say, oh, you told me I should add and subtract first all the time. But that 4 is all being divided by 2. So we want to fix that or undo that by multiplying by 2. So like Reagan said, what we're going to do is we're going to multiply each side by 2 to begin with. So this is going to cancel. 2 over 2 cancels. I'll be left with just x plus 4 here. And then 8 times 2 is 16. So I got rid of that fraction, and now this problem looks pretty easy to solve. It's a pretty easy one-step equation there, hopefully. And in order to get that x alone, what are you going to do now? Oh, it should be x minus 4. Oh my gosh, you guys. Holy cow. I need to like go back to bed today. Yikes. X minus 4. like, I know what the answer is. I'm like, that's not going to give me the right answer. Thank you. All right, what are we going to do next now? How are we going to get that x alone? Add 4. So, bless you. So 16 plus 4 gives us our 20, which I knew should be the answer, but like I was like, why is that not working out? Well, I wrote the problem down wrong. Now the next one is kind of a similar question. It has a fraction in it, but I'm going to suggest that you work it a little bit differently than you did this one. I probably, in this case, wouldn't get rid of the fraction first. Do you see the difference there? So the one, the whole thing is being divided by 2 versus this one, just the 2/3 is by the x. So what do you guys want to do first in this case? Yeah, let's move that 4 over. So we're going to move that 4 over first. So I get 2/3 x equals 8 and 4 is 12. Guys, you should be taking notes. Please remember we do notes quizzes. You want to be able to make sure that you have all the notes written down that goes with this. Any thoughts on how to get rid of the 2/3? We talked about this a little bit last time. That 2/3 is being multiplied to x. Yeah, Justin? Yeah, and so she's kind of talking about doing it in 2 steps, which is perfectly fine. So I'd probably do the multiply by 3 first, but just probably, it doesn't really matter. It won't change it. So what she's suggesting is we want to get rid of this 2/3. So she's saying let's multiply by 3. So 12 times 3 is 36. And then once we have that, then it's pretty clear that we need to divide by 2. Did anyone do anything different? You can divide by 2/3. Your calculator can do that for you. Divide by 2/3 works. Yep. Otherwise, do you guys remember what we said about dividing fractions? What do we do instead? Multiply. Yeah, the keep, change, flip. You could have just multiplied by 3/2 right away. So just that you guys know, when you're at this point, 2/3 x equals 12, you could multiply by 3/2. But I do like this. I mean, I don't mind showing an extra step, so I kind of like the way that Justina suggested. Otherwise, this also works. Either all these different ways you guys suggested will get us to 18. Okay. How about example 3? I think this one looks way worse than it is. Ollie, what did you do to yours? I think you got it.
Well, I did 3 times on both sides.
Yeah. So he multiplied this by 3. Kind of like what Reagan had suggested over here. It looks like it's all being divided by 2. This looks like it's all being divided by 3. If I do that to this side, I have to do it over here. Why is that so nice on this one? Yeah. Yeah, they get to cancel on both sides. So I'm just left with x plus 4 equals, they cancel on both sides, equals 5. So it gets a lot nicer there and kind of squared away a little bit easier. The long straight hair, she was like. I know. Well, I know when she was here, I was like, I'm sure that's a student we have already. It never occurred to me that was our new student. Like, I didn't even say hello. I just let things go. All right. Now to get our excellent, we're just going to subtract 4 from each side. So 5 minus 4 ends up being 1. All right. And then I want to talk to you guys about the next 2 problems, and then we'll stop and do some whiteboards before we get to the word problems. So, do you guys know anything about example 4 that looks like helpful or good about it? All the denominators denominators are the same. So kind of like the last problem, this is kind of a good thing. If all the denominators are the same, just like they were over here, and Ali had said, let's just multiply each side by 3, we can do that here as well. So if I multiply each of these parts by 3, all the 3's are going to get to cancel. If I multiply this by 3, this one by 3, this one by 3, all those denominators will cancel. And I'll just be left with 1x plus 2 equals 5. Yeah. So we can get rid of all those fractions. So really, I mean, to show even the divide by 3 part, you probably don't even really need it. And then to get our x alone, we're just going to subtract 2. So then, weird enough, x ends up being 3. Which is a coincidence, not anything like to be like, ooh, if the denominator's 3, maybe the answer is always 3. That's not the case, because it didn't happen there. So the question is, on example 5, what happens if the denominators aren't the same? You could, so yeah, we can make a common denominator, but what I'm going to suggest is we use common denominators to actually cancel the fractions out. So what we're going to do here is we're going to, like we did here, is we had a common denominator of 3, and we use that to cancel all the fractions. What's our common denominator between 6 and 4? What's the lowest common denominator? Maybe is the better question. 12. Now 24 works. 12 is a little bit better because it's smaller. What we can do is 12 is our common denominator. We can multiply all the parts by 12. So you might want to write that up here with these. So we can multiply all terms by the common denominator. Now this first step's going to seem like a pain, and then once we do it, you're probably going to like it, because there's not going to be a fraction anymore. So we decided that common denominator is 12. So I'm going to multiply all of these by 12. Now it's going to get a little jumbled in here, because I'm going to multiply 12 here and 12 here, but there's also a term right in the middle that has to also get multiplied by 12. Initially, again, this might seem like a kind of a weird step. But what happens when I multiply 5, 6 by 12? Something kind of nice happens there. So the 6 and 12, you can simplify that to be 2 over 1. So this becomes 5 times 2x. So this is 10x. So 12 times 5, 6 is a really nice number. It's 10. Plus 12 times 7, the 84, I believe. Right? And how about a fourth of 12? It's just 3, because it's 12 over 4, which is just 3. So what happens here is we get rid of all those fractions without a ton of work. We just did a quick multiplication with those. Now I want to get my x alone, so I have to move that 84 over. Now I'm going to warn you guys already, this is not going to be a nice answer. That doesn't mean we're wrong. So a lot of times we get kind of freaked out if the answer is like a decimal or something like that. 3 minus 84 is a negative 81. So then we divide by 10. So negative 81 times 10 is a negative 8.1. Alright, so I'm going to send these first couple rows to go grab whiteboards, markers, erasers, or napkins, or Kleenexes, or whatever else is back there. right, next couple rows. Sorry, guys. You guys want to go grab a marker board, eraser, Kleenex. So we're going to do some problems on our whiteboards using 1 and 2 step equations. So just so you guys know, it'll be both types of the last couple days here. Hopefully start relatively easy and then work our way a little bit tougher to solve that. So you're solving for x. It's kind of more like what we did last class. Yes, good job. Yes, good work. No, not quite. Yes. Yes. What's that? Good, thank you. I saw it. Works are good. No, it's okay. I know it's like a little rusty. All good. Yep. Yes, thank you. All right, so in this case, remember we want to treat each side of the equation like a balance. So whatever I do to the one side, I have to do to the other. So I'm going to subtract 4. So I got 5x equals 19 minus 4, which is 15. And then once I have that, 5 times x is, I want to divide by 5. So x ends up being 15 divided by 5, which is just 3. Let's see. So let's get crazy, throw a fraction in there. Oh my gosh. Not a bad one, I swear. So we're going to solve for x. That's a minus 9, sorry. Not quite. Yes, you're good. No, on this stuff, you're not, don't erase everything though. This is being divided by 2. What's the opposite of divide by 2? Right? We're close. Oh, so this one is different than the one we did here. You don't want to multiply by 2 first. So, don't listen to writing. No, it's okay. So same thing here. If you don't want to multiply by 2 first, you want to get rid of that 9 first. Not everything's being divided by 2. So kind of different than what we did because the 9 is part of the fraction. I know, this one's tough. This is different than example 1 we did. Oh, this should, well, see, I'm trying to challenge you. So now rather than dividing by 2, now we can multiply by 2. Only thing is, this should be plus 9, I think. It was minus, you're going to be plus. And then that changes that to a 20. Not quite. Oh, wait, because I don't see anymore. Yeah, thank you. Yes, you're good. So, oh, sorry, 11 plus 9, sorry, 11 plus 9 is 20. This should still be x over 2. And then undo that 9. Sorry. Okay, are you okay with where we're at right now? We added 9 to each side. And 11 plus 9 is 20. These guys cancel, that's where this.
Wait, that's just bigger sum. This one.
Yeah,
It's
there you
not
go.
my fault.
Okay, guys, so this one was a little bit of a rough one. I'm sorry, I got a little crazy with like trying to challenge you. Just a little crazy. Okay, so we have minus 9, and then the times or the divide by 2. So the question was, this isn't exactly like our first example because it's not all being divided by 2. So I still want to get rid of that negative 9 first. So I get x over 2 equals 20 here, 11 plus 9. And then x is being divided by 2, so undo that, I'm going to multiply by 2. So 20 times 2 gives me 40. All right, let's try. I'm trying to find some with like some different signs in them here. Okay, let's try. Kind of a weird question. And it might be something that you can see the answer, that's okay, but you want to do the work behind it. Yeah. Yeah, you're good. Yes. Okay, you're good. Okay. Yes, you're good. Close. When you move that over, you're still a negative in front of that. Keep that there. And then we get rid of that negative, so we can like divide by -1 or multiply by -1, so you're going to change both of these signs. You're close. You're not quite there, you guys. These guys. Close. Yeah, that's all it is. That's all it is.
Literally just.
So then at this point, that negative is really like a -1 being multiplied by x. So we're going to get rid of by dividing by -1. Guys, this one's a little bit goofy. I know it's like seems so obvious maybe to some of you guys, like what the answer is. But then some of you guys, you're really super close, and I kind of want to talk to you guys about how kind of to get there. So this negative is kind of throwing us off here a little bit. So if I want to move this 12 over, I can. If I do it this way, I'm left with a negative x equals a -1. I can't just say that x is -1. That x is negative here. So really, we talked about this last time. It's kind of like that's a -1x. And I have to get rid of that -1. So I'm either going to have to multiply or divide both of them by -1. I need x to be a positive. Then that makes this -1 over a -1, which is a positive one. Kind of a weird question. Let's go back to maybe somewhat normal here. was much better. Confidence back up again, hopefully. So we have to move that 1 over. So I get 7x equals 14, and then I divide by 7. So x ends up being 2. All right, let's throw a couple more up here. I'm going to throw decimal in there. So you might want a calculator. Decimals aren't your favorite thing. All right, so this is kind of like our warm-up question. So those are all decimals, so 1.2 and 4.3 and 1.7. You might need a calculator for help on this one. Good work, Reed. How was that the one you did the fastest? Like out of all of them. Not quite. Not far off, but you're good. Good job.
No.
Yes, you're good. You're good. You're good. There you go. I figured out how to do this. All right, so this one is still have trouble. Good work. There you go. Good work. I think I saw mostly right answers here. Then there's just a little mistake. There should be an X here, so that matters. So we want to add 4.3 to begin with. So I get 1.2x, and this is going to equal 6 over here when I add those two. So then when I divide by 1.2, probably not something you want to divide by hand. That ends up being 5. All right, let's do one more. Throw another fraction here, guys. I'm going to change things up. I'm going to put it on the wrong side of the equal sign so that should be an X. Sorry. So what is X here? Good work. I don't think so, man. It's not going to If you check that, it's not going to work. I don't know. Your side. Yes, yes, yes. Yeah, that's good. Let's see your side. Your elbow. So this is being divided by 5, so I would leave that. I'll get rid of the 13 first. The add or subtraction because we want to get rid of first. Yes, yes. Remember, you want to undo what's happening to x. So we're going to move this 13 over. So we get 4 equals x over 5. And then we'll multiply each side by 5. So we find out x would be 20. Alright. So why don't we send the first 2 rows again to go clean up their boards.